Okay, and so today, well, up to now we've looked at all the other operations under matrices. So today we've moved from addition, subtraction, multiplication, and we're going to see what about division. Well, that's it. Yeah, we can't do matrix division. So instead, we are going to have a quick look at this thing called inversion. Okay, so we are going to be inverting or finding the inverse of a matrix. Okay, and so basically we know, say for example, if I had the number 5 and I wanted to multiply it by its inverse, well, the inverse of 5 is 1/5, and that would give me the answer 1. Similarly, say if I had the number 3, and again I wanted to multiply it by its inverse, well, its inverse here would be 1/3, and it would also give me the number 1. And so what we want to look at here is, it's impossible for us, we can't divide matrices, but we can multiply something by its inverse. So whether the inverse of a third, which would be 3, or the inverse of 3, which is a third. And those two multiplications together, when they're multiplied by each other, that they give us 1. Now we don't have 1, so to speak, in a matrix, but what we do have is something called the identity matrix, and that's what we really want to look at here. So in the identity matrix, if we had basically the identity matrix, it's always represented by the letter I. And for example, a 2 by 2 matrix, its identity matrix is 1, 0, 0, 1. Okay, if it was a 3 by 3, we would have I is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. And so you can see the big or the important thing, or the pattern with an identity matrix is the diagonals only have the value of 1 and everything else has the value of 0. And so we could very easily, I'm sure, maybe pause the video for yourselves now and see if you can draw a 4 by 4 identity matrix. Okay, and so now that you've that done, you should have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. I'll just move this up a little. And the last row then is 0, 0, 0, 1. And that would be identity matrix that's 4 by 4 in its dimensions. Okay, and I suppose the important thing that we want to remember, or that we want to know, I suppose, or that we need to learn, is that if I take any matrix A and I multiply it by its inverse, A inverse, then my answer is going to equal to the identity matrix. Similarly, if I was to say A inverse times A, that's also going to give me the identity matrix. So similar to what we had here with our fractions. Okay, and so we're going to look at how do we get this inverse, okay? So here we're going to look at a basic matrix, and we're going to call that matrix A, and we're going to say, well, it has the elements A, B, C, D. Okay, so there's 2 steps. Step 1 to getting a matrix, and that's essentially so we need to find its determinant, and then we'd multiply that. So a determinant, that's a new word for us, a new term for us. And basically the determinant of a matrix is quite simple. It is 1 over, and we take the 2 diagonals and subtract them from each other. So AD is the first diagonal, So we've AD, and then we subtract the other diagonal from it, which is BC. Okay, so we'd have 1 over AD minus BC. So that's 1 over the determinant, AD minus BC. Our second step, so we swap the first and fourth elements and change the sign on the other two. And so our inverse, our A inverse, becomes A inverse is equal to 1 over the determinant, so 1 over AD minus BC multiplied by, well, so I have to swap the first and the fourth element, so that's, I'm swapping A and D, so D moves up to here, and A is down here, and I have to change the sign, is that right it says? Change the sign on the other two elements, and so I'm going to change B to minus B and C to minus C. And so that's how I get the inverse of a matrix. Okay, so we're going to do one very quick example. Okay, so here in this question we're asked if A equals 2 minus 3, 5 minus 1, find its inverse. Okay, and so just for easiness sake here, then I have A inverse, my formula here or my method, so it's 1 over the determinant, AD minus BC. Okay, and that's multiplied then by the adjuvant of A. So we've had conjugate before. Adjuvant is similar in that there's a change, and here it's that we've swapped position of A and D, and we've changed the signs of B and C. So our formula again for the inverse of a matrix, A inverse is equal to 1 over the determinant AD minus BC, and that's multiplied by the matrix, the adjuvant of the matrix, where we've swapped places of A and D and we've changed the signs of B and C. Okay, so here we're going to get the inverse of A. Okay, and so here we have A inverse, and that's going to be equal to, well, 1 over, here we're going to do, I'll do A in black, so 2, I'll leave D in blue, so that's 2 times minus 1, and then that's minus, and here we'll do B and C, so minus 3 times, here I'll go in black again, so for number 5. So that's the determinant of the matrix. And that determinant then is multiplied by the adjuvant of the matrix. So that's where I swap the positions of the first and the fourth, so the 2 will come down here, and minus 1 goes up into its position. Now the minus 3 in here, well, that I change the sign on it, so it becomes plus, and my 5 becomes a minus 5. Okay, and so I continue on here. A inverse is equal to, well, 1 over 2 by minus 1 is minus 2, minus by minus is plus, and 3 by 5 is 15. And here I have minus 1, 3, minus 5, and 2. So that's my matrix. Okay, and so we can see, well, minus 2 plus 15, that's going to give me 13. So here I'm going to have 1 over 13, that's my determinant, 1 over the determinant. And I have minus 1, 3, minus 5, and 2 inside my matrix. And so just tidying it up is just multiplying in that 1 over 13. And so here A inverse then is literally going to be, so A to the power minus 1, or A inverse, is equal to, well, minus 1 over 13, or minus 1 times 1 over 13 is minus 1 over 13. As you can see here, all we have is our basic multiplication by a scalar. So here is 3 over 13, here is minus 5 over 13, and here is 2 over 13. And that's my answer for A inverse. Now, the amazing thing here about the inverse of a matrix, I know if I am to multiply a matrix by its inverse, I will get the identity matrix. So in a 2 by 2, we said that the identity matrix is 1, 0, 0, 1. So maybe pause the video and see if you multiply both those matrices together, will you get the identity matrix?